Hello, my name is Ramin Shahbazi and I am a graduate student at the University of British Columbia at Computer Science Department. I will be presenting the paper titled API2Com on the improvement of automatically generated code comments using API documentation. Code generation is the task of predicting readable comments given a piece of code. As software evolves, the comments are usually missed or outdated, so it is very important to develop an automatic technique to generate or update comments. Here is an example showing a Java programming language method and the respective comment, which explains the functionality of the method. A comment generation method model receives the method as input and generates the comment as output. In our proposed method, we are trying to leverage the predefined APIs used within the Java methods to improve the comment generation. Each Java method may use several predefined APIs, and these APIs in fact are defining the functionality of the enclosing methods. For example, in box above we can see a method and the respective comment. Within this method, one predefined API named isSynthetic is used. We extract the documentation of this API from JDK documentations, which is shown in the box below. As we can see, this is very similar to the method comments, and therefore we can use this to add more context to the comment. So the idea is to use this API's documentation as a separate inputs to the model to improve the performance. Here is the architecture of our model. We are using a transformer model. We incorporate API documentation and abstract syntax tree as two separate inputs to the model in addition to the source code. A typical transformer model contains one encoder and one decoder. Our model has three identical encoders, which each one of them receives one input, and the output of these encoders are concatenated and used as the input to the decoder. To the best of our knowledge, this is the first time API documentation knowledge is leveraged with transformer model for the task of comment generation. We will be presenting the experimental results through two research questions. First one, how does our proposed approach performs compared to the baselines? We are using 4 different baselines to compare our model with, and also we define 4 variations of our model to have a better comparison. The variations all have the same architecture, but each accept different inputs, as shown below. Different evaluation metrics are calculated for baselines and proposed model variations. Our model, the API variation, the one that receives code and API, outperforms all other models except transformer-based model, as we can see in the table. Transformer-based model is actually using relative positional encoding and copy attention mechanism, which makes it better than other models. We further conduct more experiments to investigate why our model improve is not significant. We divide the dataset based on the frequency of APIs, 1 API, 2 API, 3 APIs, and more. Next, we run 2 variations of our model on these datasets, the one which accepts code and the one which accepts code and API. From the table, last column, we can see the improvement of proposed approach decreases as the number of APIs increases. We relate this to adding longer text and therefore noise to the model. As we can see, the average percentage is decreasing in the last column. Here is an example which shows the noise more clearly. In the box above, we can see the original comment from the developer and the comments from simple and API version model. The proposed model and the API version model is performing worse. It is less similar to the original comment. In the box below, we can see that too many APIs are used within this method, actually 6 APIs. And the concatenations of the API documentation, as we can see, would be too long and misleading. To summarize, we, for the first time, used integrated API documentation knowledge to a transformer model. We also conducted human evaluation for simple and API variation, and the result showed adding APIs improved the performance, and also we observed that as the number of APIs grows, the performance decreases, which we relate that to the longer text add more noise to the model. And finally, we can conclude that API documentations are useful, but certain techniques should be developed to only retrieve the informative ones that can help generating better comments. Thank you for your attention.
All right, thank you, Ramin, for the presentation. So I have a first question for you, which would give people the time to come up with other questions. So my first question is, you evaluated the generated summaries by evaluating their similarity with the reference, right? Do you think that performing a human evaluation differently could yield different results? So, for example, evaluate the summaries in terms of, ask people how do they think that the fluency of the summary is, or whether it's concise or consistent with the method, etc., as opposed to asking them how similar are they to a specific reference. So Ramin has a technical problem. We cannot hear him, but he would be answering the questions in the chat. So you, Ramin is saying that they evaluated the human summaries based on the similarity, and you're saying that it has same results. I would might disagree with that. I'm not sure if it will yield similar results, hence my question, but we can take this offline if you want afterwards. So there was a question from Philip asking, how did you evaluate the quality of the summaries in terms of what metrics did you use? And I'll let Ramin answer this. So Ramin, in case you didn't hear, the question was, which metrics did you use for the evaluation of the summaries? So Ramin is saying that they use BLEU, Meteor, and Rouge. All right, so there are other questions. Unfortunately, we're running out of time and we will move to the next paper, but please take this discussion offline in the chat and ask Ramin other questions.